Here is Lab Group 4-3's presentation for Lab 1, Sensor Calibration. Sensors are devices that react to some kind of physical stimulus and then convert said stimulus into a measurable value. They are extremely important for a wide variety of common products and are important to understand. A variety of such sensors can be seen in this photo. One important aspect of developing and understanding sensors is calibration. In this specific experiment, the goal is to calibrate two sensors, one for weight and one for acceleration. We achieve this by relating their values produced by the Arduino to a physical value. To calibrate a sensor, a relationship is developed between the physical variable being measured and the sensor output. Most sensors convert their physical reading into an electrical signal, which is what happened in this lab.
For the first half of this lab experiment, a strain gauge was connected to an Arduino using an ADC amplifier combo. The amplifier was important because it allowed for a higher resolution and therefore more accurate weights. Then the group used a calibrated mass set to record the Arduino outputs and use that data to get a calibration equation, which was then used to determine the weights of three objects of unknown mass. Our group chose an almond, a mechanical pencil, and a dollar coin. For the accelerometer portion of the lab, a 3-axis accelerometer was also connected to the Arduino, and the accelerometer was placed on a jig that ran through a series of angles, both positive and negative. The outputs were recorded for all 11 angles, and a calibration equation was later found. And then the accelerometers moved rapidly across the lab bench and data was recorded. All of the results can be seen on the following slides.
Shown here are the results from the load sensor portion of the lab. The mass value versus ADC value can be seen in the plot. From this, a linear regression was used to determine the calibration equation relating mass and ADC. The equation was then used on the objects the group chose. The mass of the coin, almond, and pencil are shown in the table here. The results from the accelerometer portion of the lab are shown in this slide. The acceleration versus ADC value can be seen in the plot. From this, a linear regression was used to determine the calibration equation relating acceleration and ADC. This equation was used on the movement of the accelerometer on the table, and the acceleration over time is plotted. The plot shows a slight pause and the back and forth motion on the bench.